Okay, I've got a very impromptu video here. I continually try to make a video about rebuilding a journal bearing turbocharger, specifically the Garrett T25 that I deal so heavily with in the 300ZX world. But at the shop I work at, I end up working on lots of Audi, Volkswagen turbos as well, just because those are, well, for lack of a better term, those are junk when it comes to having issues. And this is a very inefficient turbo. Don't let me get into a match about which one's better. They're both old, and the Volkswagen version is a newer version, but most of Volkswagen's turbos really are laden with cracking problems and oil seepage problems. And this is an ancient turbocharger design. This came out in the 80s, not very efficient compared to today's newer standards. Anyways, I always end up trying to make a video, and for one case or another, usually for the fact that the job has to be done quickly because I have shipping dates for a customer and whatnot. I can't usually make one. So in this particular instance, I was starting to rebuild this one. This is one I had laying around the house. I picked up probably from Woody 75 off of twinturbo.net as a core to get an extra set laying around the shop. I usually have them go machine, so I got a spare for my engine. Anyways, this particular turbo has turbine damage, along with the exhaust housing is damaged, and so is the actuator leak. So for lack of a better term, this is not a good viable candidate for me to rebuild. It'd be worth just keeping all the parts that are good for another turbocharger needs repaired, add it to my bin of stuff until I get enough parts to build one good one. So I went ahead and actually put the majority of a rebuild kit in this one. I'm going to kind of do a quick teardown. Everything's real loose. So I thought I would do a real quick teardown for you and kind of show you the ins and outs of it real quickly. If you can't get the turbo out of the engine and you can't get the exhaust housing off by pulling the 4 bolts that usually need to be heated to pull out before otherwise they like to snap, and you can't get the big snap ring off, then you probably don't possess the capability to rebuild a turbo anyway. So if you can't get this far, by all means, please watch the video, but it may be outside of your realm of mechanical ability. So like I said, there's one large snap ring that goes here that actually pulls the intake of the compressor side off of the turbocharger. It's a rather large snap ring, and there's a couple tools you can use to get those off. I have a rather large set of Matco ratcheting snap ring pliers. I use those, or what I've been using for a long time before I bought those was a set of angled like $5 Advanced Auto Parts, super cheap. Those pliers that have like a 37-degree angle or something on them, that I've ground down the tips so they grab very well. These actually work almost better than the snap ring pliers from Matco, but the other ones are significantly larger, so you get much more leverage. It's very easy to take that snap ring off. And then, like I said, the other side on the exhaust housing, there are 4 bolts with clamps. Reach into my bin here. This is what one of the clamps looks like. This is a new one, but the clamps go around the housing to actually retain the center housing rotating assembly inside of the turbine housing. And there's 4 bolts that go through them, and notoriously they will break. The majority of the issues with that is that the 2 housings expand and contract so much, and those are just a heat treated bolt steel, so it usually gets seized up in there pretty well. If you just heat up the housing with a torch, then you can usually pull the bolts out. So once you get to that far, you're here at this point. Now this is a 5/16 or 8mm 12-point nut. Usually, if it's not ever been rebuilt, it will have a nut that has a slot cut in it somewhere, showing where it's been, right there, where it's been balanced, and they use that as one of the areas to remove material in order to balance the center rotating assembly. So that is actually left-hand thread, so you will make a tightening motion to remove that, and it will not come off by your hand. You usually have to use a ratchet or an impact. I use a small electric impact to take that off, and it zips right off. I can usually just hold the turbine housing with my hand or with with a glove on. You want to be real gentle with the fins here. This one was damaged, I think, due to overheating issue, probably just over boosting it or a lean condition or something. At that point, you're going to want to take the turbine shaft assembly, which is the exhaust wheel, and the whole shaft is one piece. And then the compressor wheel is a separate piece. Now, if you would like to mark these before you take it apart, I just rotated it, doesn't matter. If you'd like to mark these before you take it apart, if you're not going to have it balanced, which I don't really recommend. I mean, I've done it many a times in the day. I've got a pretty good relationship with Jim and Jerry over at G-Pop Shop in Springdale, Arkansas, and because I'm in the Tulsa metropolitan area in Oklahoma, we have a UPS facility in each place. So if I do ground shipping, if I ship it before noon, Jim and Jerry will receive it before 10 o'clock a.m. the next morning on just regular UPS ground shipping. And because they have a UPS facility very close by. So if you can use UPS to those guys, it's probably the best. You get the most efficient and quick shipping. Even ground, I get that overnight service. So anyways, I would recommend having it balanced. It costs, I believe the normal cost to have a single assembly balance is $65. When I first started out, they were nice enough to give me a deal on the second one at $55. Now we have a pretty good deal set up. I'm not going to go into the pricing I pay now. I'm a very high volume customer, but on a normal basis, it's $65 for the first one, $55 for the second if it's the same turbo and you send them both at the same time, because they don't have to set up the machine separately. It takes a good amount of time. I worked in a shop where we had balanced turbocharger assemblies before, along with other assemblies, and setting up the machine can be quite cumbersome for each specific application. So that's where a lot of the time really goes, is just setting up the machine. The balancing itself isn't that bad. It's just removing some material to get it to balance right. NVH machines are really, really expensive, so I mean that's a very, very reasonable cost to have one done, and they do a great job for me. They've done lots and lots of these turbos. They've done dozens and dozens for myself, and I'm sure thousands for other customers. Anyway, so you wouldn't worry about marking it, but if you just hold the turbine wheel and spin the compressor wheel and pull, it will slide off. At that point, you will have the housing here. Now, where you'll see a lot of issues on this one, the original housing was all ate up from overheating as well, or oil contamination does that. They're pot metal. They're very thin metal. They're made to disperse heat very quickly and not expand and contract at very quick rates. So there's a snap ring there. So you'll just have another smaller set of Matco snap ring pliers. It doesn't have to be Matco. It just happens to be the only tool guy that comes by our shop. So you will squeeze it and remove. And once that snap ring is out, you can get that out of the way. I use Garrett brand rebuild kits, and those will almost always come with a new snap ring. Now the housing here will come off. Usually not that easy. I left a couple piston rings off, and I'll show you where. I call them piston rings. They're sealing rings, but they're similar design as to a piston ring. They're right here. Now there'll be an O-ring that sets right inside of this housing here on this lip. You'll see where I'm talking about when you go to pull it out. It's usually stuck in there, so you usually got to pull it out with a small pick, which I happen to have right here. Don't reuse those O-rings. That's where a lot of your leaks come from. So at that point, you would I usually have a towel surface, a soft surface. You could take it, and if you just knock that shaft like that, then the turbine will come out. Now this piece fell out. I have a 360-degree thrust bearing that I put into this one to show you, but the original style used a 270-degree thrust bearing, and what that literally means is that this is a thrust bearing. It provides the bearing function or cushioning for the shaft to move in and out of the turbocharger. So here's a turbocharger and the compressor housings. The wheels would move in and out. If there's a lot of radial play that way, it's usually because the thrust bearing's worn out. Now from the factory, they have 260 degrees of coverage. You see that's not a full circle, it's missing a chunk. That makes it 270 degrees. Now when you add a 360-degree thrust bearing, see how it's completely encased there, all the way around the hole there where the shaft would go? You get better support to it. So more coverage, just like a larger brake pad or a larger rotor would cause more surface to actually have to disperse that same friction that's happening. No matter what, you have the same amount of force on it, so the more surface you have, the less stress that every little bitty square millimeter of it gets, so the longer it should last in theory. So I try to replace all the 270s with 360 degree because it's just better. So 360 degree, the bushing piece would just slide in, and it would have retained itself when I pulled that piece out. Now usually this piece will be retained within the cover. They're the smaller of the two piston rings will snap into place in this one here, right around this bevel. You'll see you'll see it when you pull it apart, but there's a bevel right there, and that goes inside of it. So we'll get these old pieces out of the way here, put that back. So you'll get that piece off, and then there'll usually be, if it's original equipment, it will have Torx head screws. A few years ago, the first couple Garrett kits I bought all had replacement Torx head screws. I believe, yeah, Torx 15, a T15. Now, for a long time, the replacement kits all had that, and just recently I started getting some Garrett kits, still coming from G-Pop shop, and they came with these Allen head. I have a large quantity of rebuild kits laying around. I probably have 30 or 40 complete rebuild kits laying around. I put them in these bins I've got over here. Well, the pieces separated, so I'm still using a lot of my Torx head ones, but the Allen head ones are even stamped 10.9, which is a grade classification for metric bolts, rating their hardness and strength and a tensile number and tensile strength. So similar to how you would hear about a grade 5 bolt or a grade 8 bolt, grade 8 being stronger of the two, they are class 10.9, sometimes incorrectly referenced as aircraft quality. That's a long story, but we'll just leave it at that. Now, the reason this particular turbo, and you want to inspect this, but the reason this particular turbo is unusable for me is there's some fin damage, and then as well on the backside, this is where the most of the heat is for the turbocharger gets kind of radiated into this housing here. If you look, there's some serious pitting and such into the actual turbine housing. Not always a deal breaker, but I find a majority of them in good condition without it, so I prefer to use the ones without it and just kind of scrap the ones with turbine damage. You can get new turbine wheels, but it's rather expensive. By the time, if you have to replace a turbine wheel and a few other components, you've pretty much bought a new set of turbos. There are many sources out there for replacement turbos that are direct from Garrett. You can get a whole new center section from Garrett for like $550, $600, an entire, this is called CHRA, and you can get them for about $550, $600. I rebuild them significantly cheaper than what that cost, but they're not directly from Garrett. They're just from a reputable rebuilder. Anyways, moving on. So there's also the larger of the two rings you see laying over here. Ooh, that one actually goes on this inner groove here, not the outer groove, the inner groove. So that's another wear item that needs to be replaced, and that's the ring that separates the exhaust gases in this housing from the rest of the turbocharger. There's one common shaft, but you want to keep exhaust stuff on this side and intake or charge air on this side. So we're going to set that aside. So after you've knocked that out, that piece will come out the back here. Now there's a very small, it's called a circlip or a spring clip sometimes. I don't really know how to explain to you to get it out, but there's a small oil channel inside of there that allows you to kind of get behind it and then just pop it out. Getting it back in is another story. I use a different style. I use a snap ring style clip. That's what a lot of the Garrett kits you can purchase come with in lieu of the spiral lock. I'm going to try to use all of its nomenclature that's used out there. So grab that spiral lock and we'll pull it out. It's called a spiral lock because it is a spiraled piece of metal. I've done a lot of those, so don't feel like it's going to go that fast for you. My first one probably took me 25-30 minutes of fighting to get it out of there. but I've done a whole lot of them, so it doesn't really bother me anymore. So that will come out. Then there should be a washer behind it. Just let it fall out, that washer. You don't want to lose any of these parts. Some of them you have to reuse. At which point you can get another pick. I'll use this shape one, and the journal bearing is just sitting in there. Usually they'll just fall out, but there's a, like I said, I've already put a kit in there. That's why a lot of the stuff is nice and clean. But there's a new journal bearing, and there's a used journal bearing, the one that came out of this one. That's the literal bearing, much like a crankshaft or camshaft, where the friction is all set on. That the shaft this section journal of the shaft actually rides on those two bearings. That's what provides the support of the center of the bearing to free float. And what happens is oil pressure from the engine usually comes in the oil inlet port. It creates a hygroscopic film which actually separates the bearing, which feels like it tightly fits, but realistically when there's high pressured oil running through here, the film creates a barrier where the two don't touch, and that literally rides on the oil. That's why oiling your turbo system is so very, very important. Anyway, so that comes out. Now on the other side, the pressure side, I was telling you about that 360-degree thrust bearing. We are going to pull, I normally use power tools, but for sake of not ripping the audio on here, we're going to just use this nut driver with a Torx bit on it. We're going to pull these out. Normally you'd have to pull these same 3 screws out to get the 270-degree bearing out. We'll get this pulled out. They're usually on there a lot tighter. Like I said, I kind of already did this to make a video finally. So this 360-degree one, there's this little insert that like I said, that's going to be different on this replacement because those two pieces together equal what would normally be the bottom piece and the top half of the same unit on a 270, but that's not possible with 360. It would be 2 pieces to get around there. And that acts as a specified washer for being the thrust component against the bearing itself on this side, because there are 2 journal bearings in this turbo. There's the other one on this side. I just pulled right out. Now there are also 2, I do not think I'll be able to get it in there. You probably won't be able to see, but there are 2 other clips in there that retain the bearings, and they push against that way and that way. Highly recommend that you replace those. Those are difficult to get out. I usually just use a pick to knock them out and push the new ones in. A lot of the Garrett kits now, again, they're a little bit different now than what they used to be, but they'd come with nearly identical style, we'll call them like a 7-leaf clover snap ring. The newer ones, grab one here on my stash, are coming like this. Now what's funny about these Garrett kits is I'm noticing the new Garrett kits look very similar to the old knockoff kits. Now I'm getting them from G-Pop, so they're not knockoffs, but anyways, so at that point you've got it all tore down, so you're going to want to have this sandblasted, being careful of this surface. This is machined, but the outside housing you want to have at least clean, maybe not sandblasted. I use a wire wheel. This is going to be very dirty and crusty on this side. I haven't cleaned it really yet. I just kind of scraped it off with a pick. But you'll want to clean it up real well and get it nice and clean. The cleaner the better. If you get anything inside the oil return hole, I was going to go over that. The hygroscopic film that's created in there's a very common misconception, and it's going to probably cause debate, and you know how I love those. There's no such thing on a journal bearing turbo as too much oil pressure. Now, there is such thing as having an underdeveloped or inadequate oil return system for your supply system. So with ball bearing turbos, restrictors in the oil lines are needed just because too much pressure will wash the bearings out. But in the journal bearing system, that's technically not true. Now you can over oil supply your bearings and under support your return system. And if you do that, if the oil can't return fast enough and you have a buildup and the oil is unable to freely flow in the pressure side out the return side, if you have like a kink or a restriction, or the hose is too small for how much pressure and volume you have coming in, it'll back up in here and the pressure builds up inside the housing, and it will push itself past these O-rings, and that's where you get a lot of smoke. So you hear there's a lot of information out there, a lot of good information, and a lot of bad information. Just my information comes from being a Garrett certified rebuilder, and I can tell you this, that for the most part you will never over oil supply turbo. You will almost always, if you have an issue with oiling that's due to over oiling, it's usually because you're actually have a system that's inadequate to return the oil back to the engine. I've seen issues that arise this where a properly sized supply and return for the pressure, everything's fine, but we find that maybe the PCV system in the vehicle is not up to par with it, and they're building excessive crankcase pressure due to blow by, and that allows positive pressure in the oil pan, so the oil is not returned carefully. I've had vehicles that have properly functioning PCV systems, but them themselves are inadequate, and we've had to install electric vacuum pumps for that, and add a larger catch can, or still a PCV recirculation. You don't want to ever open atmosphere vent because that's technically illegal, I guess. But beyond that, it's you want a PCV system just like you want an EGR system to function properly. A properly functioning EGR system will actually reduce the probability of detonation or pinging, but that's a whole other video. Anyways, I just wanted to touch on that real quick about the oil supply issue. There is one caveat to that. You can over oil supply that hole's not getting any bigger without machining. So there can definitely be a probability of you supplying too much oil pressure for just how much the turbo can really return. But if you're at that point, you should be looking at oil pressure issues anyway. If you've got that much oil pressure, you probably have other problems that you're creating, let alone a little bit of smoke through the turbo and exhaust system. Anyways, moving on. So you get all that stuff, you get it cleaned, and putting it back together is pretty much the reverse of teardown. You kind of, if you could take all that apart, you can put it back. So you just put the journal bearing in. We'll put the washer in. I'm not going to fight with the spiral lock for you, but the trick to that is separating it, taking one end and holding it with a small pick down inside the groove, and then just running the pick around and snapping it into place, or replacing it with a snap ring style that will retain it. That's an option. Then you would pry off the ring from here. That's very difficult, and you'd install the new ring. Not doing that on this because we're not rebuilding this turbo, and I don't want to fight with it, and you can damaging this ring here, trying to get it back off. You want to put it on once and not take it off, just because if you stretch it out, you may not get the turbo to lock in, and I'll talk about that in just a second. So you get like I said, you get the washer put back in. Don't forget your new plate. This will be all, there's the original one, this will be all ate up and burnt up. And make sure you get that off. Sometimes I've had quite a few of them be stuck on here, and you don't, if you know what you're looking at, you won't notice it, but that needs to come off. That's comes a new one for a reason. Then you'll put the thing through. This is going to hesitate here normally because there's going to be a that O-ring I talked about, and it'll be nice and tight. So I'm going to put a little assembly lube on it. Don't use like what is it stuff called, Lubriplate or Lubriguard. It's like a white lithium style. It is actually a great assembly lubricant, except for if you're going to let the system set. If the system is going to set and be unused, it actually will get dry and can cause issues. So I like to use just a petroleum base. Like Permatex makes a good one. We use BG. Not everyone has access to BG products. I understand that. So Permatex makes this red assembly lube, works really well. Very sticky. It's almost like a Lucas consistency. It's kind of stringy and very has a nice viscosity for assembly lube. It's kind of thick, but it'll work. So you get that O-ring in there with a little assembly lube on it. You probably have to tap it with a rubber mallet to get it to pop all the way in. Some you got to pop pretty hard, and some of them just tap right in pretty easy. I did that in that order. I apologize. Actually, before you snap that in, you're going to want to set your new journal bearing for this side in. I'm actually probably going to go ahead and put the old ones back in here just for the sake of not having to put them back, take this thing back apart again, put all the new pieces back in my box. Anyway, so you'll put that new journal bearing in. You'll take your new, now on the 360 degree one, you will put this piece in with the bevel hanging up. Now the 360 degree journal bearing, there'll be two sides. There'll be one that's got this fourth little hole right there by my finger. You see there's not one on this side. It's actually right there on the inside and right there next to it. Now that's where oil comes from this supply hole right here in the housing and goes around this thrust bearing to help supply oil to the journal bearings, and the return is right there. That's where the oil return goes and drops back off out the outside and goes back to the oil pan. So on the 360 degree one, you lay that piece in, then take the journal bearing with the oil hole down so you're not blocking it off, you're allowing the oil to flow, and put that in there, and you'll bolt that in. But since we're going to put this one back together with the old pieces because we're not going to use this turbo, we'll set those off to the side. We'll go ahead and take the thrust one. You'll see there's some oiling holes and a divot there where there would be no oil hole. So we want to go ahead and put this back in the same way that we found it. There's a channel here for the oil, so that will go down. And then we'll take this like that. Take our bolts here. I guess we'll use the new one. It doesn't matter. I think I threw the old ones out. I'll try not to keep a bunch of them. I thought about that, and then I was like, oh, I dug half of the stuff out of the trash and thought, all right, let's make a video. Haven't been able to do that. So I will throw just a couple of these bolts in here. Get this set back to the center. And sorry if you can hear my dog whining in the background. My wife got a little poodle that's whining at my daughters because they're in the bedroom playing by themselves. Let's see here. So you get that back in. Now that O-ring will be sitting right there. You'll want to put that back, the new one in, the new one, not the old one. I'm not going to put it back in. This thing is going to go over for parts. Take the old housing, put that back in. Normally you'd have to pop that in. It'd be a little harder than that because that old snap ring would be on that washer I showed you about. So when that piece is all back together, you'll take this snap ring. I guess I'll put it back in. It's easy enough to get out. I got a whole box of these if I need them. That'll go in there. Now before you put those journal bearings in, like I said, you want to put lubrication on the outside of the journal bearings, on the inside of the journal bearings. If you want to just dip them in motor oil, that's fine too. Then you'll take that shaft that will not have this bearing on it. You will have already put it in and put the spring lock and put the washer and then the spring lock in. It'll be retaining that in the center housing. And like I said, you'll take that and you kind of have to fiddle fart around with that to get it correctly. So you shouldn't have to force it. You can cause damage. You get it there and you'll tap it with a rubber mallet or a plastic face dead blow or something that won't mar up or mess up this metal here. When you send off your turbocharger to have it balanced, you can send the wheels inside of the center section if you'd like, or you can send, for cost savings, just this assembly, the turbine assembly with the compressor wheel and whatever nut you're going to be using. This is the old one. Usually kits will come with a new one. Prefer you send the new one. If you send them this assembly, they're gonna balance this. They're gonna spin this up and balance it. They're gonna mark it for you. They're gonna mark on the back of the compressor housing with some markings. If you have G-pop do it, you'll get a nice little Sharpie mark, probably from Jerry saying GP for G-pop. Then they'll mark the end of the fin, across the fin in the housing, and the nut, and the mark with a grease pen ink marker or whatever, and then the turbine housing the same, and you'll notice that when you get it back, it'll be lined up a certain way, and they'll give you a little instruction sheet about turbo break-in. When you put it back together, you'll want to just line that up the best possible. What I like to do is pick a spot in the housing, like the oil inlet and use that as my marker for making a, sorry, trying to get this straight there on camera, trying to use that as making my straight edge to line up the notch, the paint mark and the paint mark. If you just look at how it looks when they send it back to you, you'll realize what I'm talking about. It's fairly simple, as close as you can possibly get. And that's the best advice I've got for you for clocking it correctly. If you just slap it back together and don't mark the old one, if you're not even going to send it off, at least mark it before you put it back together. You'll hear a lot of stories about people saying, oh, I just put it together and it was fine, and that's possible, but most likely the assembly being out of balance will cause some kind of undue wear on the assembly. So that's what we've got. You want to make sure that before you take the compressor housings apart, probably should have put that in there beforehand, that you want to clock them. I usually pick the oil hole, put a dimple on the outside of the compressor housing somewhere to line it up, and do the same on the exhaust housing. That way when I go to put them back together, I know I just line up my dots with the center of the oil inlet or whatever location you choose. I always do the same spot so I never get confused. Which point you've successfully rebuilt your turbo. Now, once you put your turbo on, to prime it, you want to prime it kind of like you do a new engine. If you can, you need to somehow either synthetically prime your oil system. I have a oil filter adapter I bought on Jegs. It's for like relocating the oil filter. I kind of just took an old oil filter and cut and put a thing on the outside of it where I can pressure the filter itself with we have a BG bottle for priming, like priming a fuel system, and I use that, fill it with oil, prime the whole engine with it, and then I know that the turbocharger's got a good supply of oil to it before I crank it up, so I'll go ahead and disable the fuel and spark system, crank the car for 8 seconds, no more than 10, that way I can ensure that everything else is good to go, and then I'll put the fuses back to undisable, to re-enable the fuel and spark system, start the car up and let it idle for about 5-10 minutes. I'll raise the RPM to about 1500 RPM and let it idle run for about 10-15 minutes. Then I'll shut the car off and let it cool down. It's just my process. There's no real science in that. It's just always what I've done. It works fine. Never had a problem with it, so I don't feel like changing it. Then I'll go and drive it like I would normally drive it and try to, there's not really a break-in period on the journal bearings. There is, but there isn't, so I don't worry about it. I just run it like I'm going to drive it. So, and that's it. That's what I got for you.